first, you need to actually make an instance of your Echo factory. And I hope that everybody here has enough Python experience to not make instances out of classes, so I'm not going to cover that. Then you need to call something that's going to actually hook it up to the reactor. Now here I've got, just for simplicity, listen TCP, which just takes the TCP port number. There is, if you're doing new cool stuff with Twisted, I would recommend looking at the new endpoint API added in Twisted 10.1. We're not using that in the lab today just because some people might have a slightly older version, depending on what version of Linux they're using or whatever. But the endpoints API is going to let you do some much more interesting stuff like connect to sub-processes or via SSH or things like that. So listen TCP isn't necessarily the best way to do it, but it is a nice simple way to get going. Then you need to run the reactor. This is what actually starts the whole show. And this is where a lot of confusion about Twisted comes in. I really want to stress this is not something you should be doing very often in Twisted code. You can call it exactly once per process lifetime. When you have run the reactor, it's running. Once that function returns, once you call reactor.stop, it's time to exit. There are a couple of exceptions to this, but I can guarantee that they do not include you, because I know who all the people they include are. 2 of them are right there, 1 of them lives in London. So you call reactor.run, it runs, it stops, you're done. This means that if you're writing a little library that uses Twisted, the function that does the work and starts things up should not be calling reactor.run at the end after it does everything else. You should really separate your code that runs the reactor as much as possible from the code that's doing other stuff. And in fact, oh, I'm sorry, yes?
You were talking at all about like concurrency and having the one industrial strength server here. You might want to have come down and come up and still maintain multiple threads and so forth.
Okay, so if you want to deal with, J.P. gave a talk at one of the early PyCons called Translucent Interprocess Service Migration. It's hard, regardless of whether you're using Twisted or not. It's not really something we're going to talk about today. We can chat afterwards, but that's like hardcore server stuff. I should note, this server here is completely concurrent. It'll handle, if you run it with ePOL on a Linux machine, it'll handle tens of thousands of connections on a properly configured machine. And I forget the most recent benchmarks, but there are people who are actively trying to saturate 10 gig with a server like this. So in order to just get basic concurrency, this is all you need to do. One more?
So if I want to start an F server, and a DNS server, and a web server all in one program, do I have one reactor that's doing all those things, or what?
Thank you for asking that question, because that's exactly what I'm trying to get across here. Yes, you have a reactor doing each of those things. Basically, if you were going to try to write, and this was the question in case anybody didn't hear it, a mail server and a DNS server and a web server all in the same program, what you would do is you would call that line multiple times. And after that second argument there, instead of Echo Factory, you'd have DNS server, and then you'd have web server, and then you'd have mail server. And you create all of those, and then at the end, you would call reactor.run, or more likely, if you're writing a program that's that involved, you're probably using a Twisted plugin, which is a slightly more advanced way to write Twisted applications. And if you're using a Twisted plugin, then the reactor's already running, and you don't need to worry about it. You just build your stuff and hook up your things to the reactor, and then it's all done. So that's another reason I like to really stress this. This is a very big point of confusion for a lot of new Twisted users, because all the trivial examples that we have end with you run the reactor, and then as soon as you're writing code for real, you suddenly aren't running the reactor anymore. So this is kind of a bootstrapping implementation detail kind of thing. It's not the sort of thing that's super important to your code, and you should learn to treat running the reactor as the thing you do when you're done with everything else and you just need your loop to get started. So, now that we've covered getting the basics of a protocol that communicates with a single client at a time, even though that server was concurrent and could handle any number of connections, they weren't really interacting with each other, let's tackle multiple clients. And I'm going to go through this a little bit faster. So this here is a server which will echo traffic that it receives from all clients to every client. So every client that shows up, if you send traffic to the server, it sends it out to all the other clients. Since you're all Twisted experts now, we're going to go through this super fast. So first, I want to highlight that constructor there, regular old constructor. Nothing special about the name echoers, nothing special about anything. It's just a Python list that we keep on the factory. The next thing I'd like to point out is that the build protocol is also just regular Python code. I'm making an instance of a multi-echo, which is the protocol up above. We're appending it to the list of echoers, and then we're returning it. So it's going to handle every connection. Each connection, which means in this case each multi-echo instance, remembers its hub. So I can do two things later. The first thing it's going to do later is, when it gets some data, it's going to loop over each echoer, and it's going to write that data to that echoer's transport. And that includes self, because each echoer before it's returned is added to the factory's list. And the other thing that it's going to do is, when the connection is lost, it's going to remove itself from the active list of listeners so that we don't end up trying to send data to clients who are no longer connected. So does anybody have a question about the code on this slide? Yeah?
I'm sorry, I got confused about the build protocol method.
Mm-hmm.
When you hand the factory, the protocol factory, to the reactor, how, like, does that get called every time there's a request, or does that get called like a finite number of times?
So the question was, when you pass a factory back to the reactor, when and how does the build protocol method get called? And the answer is, for each new TCP socket. Do you know the Unix sockets API? BSD sockets?
Not intimately.
Okay. If, for those of you who do know that API, the timing is whenever accept returns a file descriptor. So, if that makes sense. But basically, when you make, like, if you were to do telnet server port, that's the point at which build protocol gets called. It's for each TCP connection. So it doesn't break down for HTTP, it's like usually once per request, because usually HTTP clients tend to associate those, but you shouldn't get used to thinking of it that way because, for example, if you have a good HTTP client that's doing pipelining, it's going to pipeline all those requests over one connection, and there's a separate API in the web server that's for separating requests from responses. Make sense?
Thank you.
So, anybody else before I move on?
I'm sorry about this at the beginning. Is all of this running in one thread? So you're actually just basically pulling out the equal and replacing whatever files.
The question is this all running in one thread? And the answer is yes. And that is actually an advantage of Twisted, because if you want to do multi-core concurrency with Twisted, the way you do it is spawning processes. We're not covering that today, because multi-core concurrency is actually kind of tricky. But yes, this is all one thread, all really